Yes, so you can see from that slide the science is about to begin. I think, so to put the science in a little bit of context, and the report provides a perspective, right, on the future governance and management of our ocean estate. And one of the big issues we're going to be facing in the future is climate change and how the ocean's going to change. It's an awfully big place, and we understand very little about it, both the physical side of the ocean and the biological side, which of course have big implications for our economy, our environment, and us as New Zealanders. So our place in the world is an interesting one, sort of smack bang in the mid-latitudes of the southern hemisphere, where essentially in this tug-of-war position between the tropics and the polar regions, the ocean temperatures here are around about 0 and they're about 30 degrees up here. So we're potentially in a very sensitive place if there are changes in both the equatorial regions and the polar regions that affect the ocean around us. And so I'll talk a little bit about that. Then, of course, the winds, the westerlies drive the global circulation, the atmosphere and the ocean, and they are changing as a consequence of climate change as well. So the ocean is a very dynamic thing. Our place in the world is a very sensitive one with respect to ocean and our climate, and essentially our culture, who we are, our economy, very much matters in terms of what happens in the ocean. Okay. So I've had some experience with the Intergovernmental Panel on Climate Change. I was a lead author, and I guess I want to step back a little bit and paint some of the global changes for you, and then we'll talk about how they downscale to New Zealand. Yeah, we love showing graphs. So this is a graph, and this is Earth's temperature since the Industrial Revolution. And the point really is that it's been on an upward trend. It's a bit of noise on it. If you look at the decadal average, there's no question that the world's warming. We say that with absolute confidence, 100% confidence. The world is warming, particularly in the 20th century and into the 21st century. And we say with almost equal confidence the world is warming because of us, because of putting greenhouse gases in the atmosphere. The thing that you probably don't realise is that 93% of that heat that's been generated from global warming has gone into the ocean. Only 1% has gone into the atmosphere. And yet we see this incredible temperature trend. The ocean has sort of been ameliorating things. It's taken up a lot of the heat. It's an enormous heat sink. But it's also taken up about 40% of the carbon dioxide. So the gas has gone into the ocean, the heat's gone into the ocean. You might think that that's a good thing because it's muting the effects of climate change, but potentially it's a bad thing as well because the ocean's warming, the ocean has carbon dioxide in it, which leads to ocean acidification. So the ocean is changing. Graphs again, but the take-home messages are in the industrial age, about a degree of warming, but less than a degree of warming, about 20 centimetres of sea level rise. Okay, from the ocean heating up, the ocean expands when it warms, and so the surface goes up, but also the polar ice sheets are melting. And that's also because of the ocean. We'll talk about that in a minute. The Arctic Ocean has spectacularly warmed, and you'll all be aware of that. It's sort of the poster child for climate change, and about 50% of the summer sea ice is now gone, so the Arctic is seasonally open for shipping, for exploitation, for all sorts of things. Let's come to New Zealand. Okay. I want to talk about two things. The first one's sea level, and they're two things that I think New Zealand's fairly unprepared for. Sea level rise is obviously related to the ocean heating. It's also related to what's happening south of us with the Antarctic ice sheet. Sea level rise will affect us in the coming decades. It will affect us this century. And there are questions around how much, how fast, what will the regional differences be? Will we get more in Auckland, less in Christchurch? Because there is a real regional signature to this. We just have no baseline understanding of how our sea level has changed and how it will change in the future. And of course there are impacts that come from that, and then how we manage those impacts. So there's the Ipcc graph, and I do apologise for the Ipcc figures. They're not all that friendly. But essentially what this is telling you is if we continued business as usual, with our emissions, this is the scenario out to 2100, and we can expect about a metre of sea level rise globally. That's a global average. The IPCC have a sort of get out of jail free card. They say, well, this is what we think is going to happen based on all our models and everything we understand about the system, but we also know that the Antarctic ice sheet is very poorly understood and could contribute significantly more. And if it does, then all bets are off. So there's a big wild card is what's happening to the Antarctic ice sheet. And this is why I'm going to make the link back to the ocean in a minute. But if we look at what's happening to the Antarctic ice sheet, what the satellites are telling us, and we have pretty accurate satellite observations going back about 20 years now, but certainly for the last 10 years, is that the ice sheet's melting. And so these big circles really just show you where the ice sheet's melting the most. And you can see clearly along West Antarctica there's a lot of melting. And the ice shelves are thinning. So the ice sheet's the bit that sits on land, they're the glaciers, and it flows towards the sea under gravity. And the ice shelves are where the ice meets the sea and the ice begins to float. The ice shelves are thinning and they're melting, and when they collapse, the ice sheets that are feeding them, the glaciers that are feeding them, flow faster and faster. And you get more discharge into the ocean. So you can see where the ice shelves are all melting, and you can see where the majority of the ice is flowing into the ocean. And so this is an accelerating trend. This is, we don't know quite where it's heading, but we know over the last 10 years it's doubled in terms of the rate of loss, and so that's accelerating. And it's accelerating because the ocean's warming. So the Antarctic ice sheet sits below, sits well below sea level. Many parts of it sit well below sea level. In fact, about 22 metres of sea level rise would come from ice that sits in contact with the ocean or below sea level. So as the ocean warms, remember 93% of that heat's gone into the ocean. When the ocean warms, the ice melts. It's a big thing to warm up an ocean. And we could switch off the greenhouse gases tomorrow. It's sort of unlikely we'll do that, but say we could, and control the temperature rise, we couldn't, the ocean would still stay warm, and it would stay warm for decades or centuries. So there's a certain amount of inbuilt climate change and commitment going on here. So the reason that this part of Antarctica is melting is because it sits below sea level, and that's where the ocean has got warm around Antarctica, and that's what the pink shows you there. So I'm not going to go into all the detail. This is an ice shelf about the size of, say, Northland. This one broke up in 2002, went from this to this over a couple of months, and when it melted, the glaciers feeding it sped up about 10 times their flow into the ocean. So one of the big consequences of ocean change and the fact that the ocean's taken up all this heat is that the ice sheets are melting and they're contributing to ocean sea level rise. And this is one of the big uncertainties for us. This is where a lot of the science is going on right now, is how much ice melt can we expect in the coming decades, coming century. I had a nice little animation to show you, but it didn't work, so I'm going to show you a graph instead. And one of the challenges is to improve the models, and the models are getting better and better in terms of how the Antarctic ice sheet is responding to climate change. These are these representative concentration pathways. Essentially, the red line is business as usual. If we keep burning fossil fuels as we are doing and we have no policy, then we follow this red line. And there's a temperature associated with that. By the end of the century, it's about 4.5 degrees of global warming. That's the path we're on. What that means in terms of the Antarctic ice sheet is that in the next century, we're going to get between 30 and 70 centimetres of sea level rise from the best, latest generation of ice sheet models. Okay? So this is double what the IPCC is currently saying. This is since the IPCC report. By 2300, we'll have 3 metres of sea level rise just from Antarctica. So if you add in Greenland and you add in the fact that the ocean's warming and expanding, you're getting numbers that are much higher than that 1 metre by 2100. They're nearer 2 metres by 2100. Okay? So that's what we're facing, at least 1 metre, but potentially more on the business as usual scenario. Okay, and then the other thing we've got to throw in here is that sea level doesn't rise evenly, and New Zealand's actually going to get a little bit more than the global average. We'll get about 10% more because of where we are in the world, and I won't go into the details of the science behind this, but there are large regional variations, and we'll get a little bit more. So we might get 1.1 metres. And then we've got this interesting situation, which is because we live in a shaky isles with lots of tectonics going on, earthquakes, bits going up, bits going down. And if you factor in, obviously, where bits go down and sea levels going up, your relative sea level rise is a lot more. And there are parts of New Zealand in red here, and we were just talking earlier about the Marlborough region, Cloudy Bay, and that is going down at greater than a millimetre per year. So, you know, if sea level is going to be rising a metre per century, this is going down at about a metre per century, so you're getting 2 metres of relative sea level rise. So, really important thing to know. Okay, sea level rise. Okay, so what does a metre look like? There's a metre for Wellington, and that's an impact, right? That's a fairly significant impact. You might argue, well, it's got a few less politicians maybe downtown, but
they're not actually in that area.
No, they're not, are they? They're just out of the picture, a little bit higher, but 2 metres will get them.
The academics and the politicians.
Yeah, the academics are well and truly safe up there, but they knew, right? Okay, but perhaps the more concerning thing is we think about sea level rise as very slow and very gradual, and perhaps it doesn't worry us because we think it's over decades to centuries. But one of the things that is a real factor is the effect of storms on that increased sea level. So for 50 centimetres of sea level rise, the 1 in 100 year storm becomes an annual event or happens several times a year. So that's the real kicker with sea level rise. And I'll just show a few, these are the scary photos Wendy promised, but that's Tamaki Drive, you guys will be aware of that. Get a king tide right now, you're in trouble. Wait till half a metre of sea level rise. And then these coastal inundation events, the big ones happening every year, that usually happened every 100 years. And Wellington's not immune. Here's an example from Wellington. We had a 1 in 100 year storm a few years ago, did quite a bit of damage, took out the Catherine Mansfield house at Days Bay, did a bit of damage on the south coast, and of course Christchurch, right? It's subsiding, so it's one of those areas that's subsiding, and it's not future-proofed, right? They're rebuilding a city. What a great opportunity to future-proof a city to ocean change, to climate change, and it's not being done. Okay, now I want to turn quickly with the last 5 minutes to ocean change around New Zealand, and what I'm talking about here is change in temperature, change in pH, ocean acidification, change in the nutrients, change in the currents, change in the circulation. And these are things that we don't fully understand in today's situation, and we definitely do not understand in terms of how they might change in the future, yet they're fundamental to our climate, and they're fundamental to our fishing industry, and to a whole bunch of other factors that are important to us. So how are the currents changing? How is the ocean temperature changing? How is this affecting marine ecosystems? What will be the broader, longer term impacts? We don't know, but there are some things we do see, and there is a picture forming. Essentially, this is the tropical influence, this big gyre of warm currents that goes around here, and then we get the subantarctic influence, these Antarctic circumpolar currents that spin off up the South Island, eastern coast of the South Island of New Zealand and off here, and the two are separated by the subtropical front. Turns out that this is quite a sensitive dynamic feature, and this tug of war I'm talking about, if the tropics start to win, the warm influence pushes down and the Antarctic contracts, and that's what we think is happening at the moment. Tropics are the heat engine of the climate system. All the heat goes in at the equator, the majority of the heat, and then it's exported poleward. So what we're seeing with global warming is the tropics warming, their influence expanding, and we're getting this tropical influence on our ocean pushing further and further south and pushing the Antarctic influence away. That's what we think is happening at the moment. So one way we can look at that is we can go back to the last time, this is using geological data, we can go back to the last time the world was 1 to 2 degrees warmer. Happens to be 125,000 years ago, and we can see what happened. Did that tropical influence push south? And the answer is yes, it did. And I was going to show a bit of an animation here, but remember we have that subantarctic influence coming up there, and we had this tropical influence coming mainly across here and down the east coast and along the Chatham Rise. What we're seeing now is this East Australian current is pushing further and further south, and we're seeing the temperatures increase, and it's starting to come across and affect the South Island. What happened 125,000 years ago is exactly this. It pushed all the way south, it pushed the sub-Antarctic influence out of the way, and it brought across the East Australian current. Instead of coming across here, was coming across the whole of New Zealand, and ocean temperatures on average were about 2 to 3 degrees warmer around the South Island. That had a major impact on the food web, on primary productivity in the ocean. It completely changed the base of the food web, and before I get into that, this is an image. I think this is based on, this is a satellite image obviously, and what it's showing, you can see phytoplankton blooms out there. Okay, so the Chatham Rise is a really important area in terms of primary productivity. The question is it changing? Is the productivity changing at the moment? We're not entirely sure. Yeah, okay. But what happened 125,000 years ago, and this is 125,000 years ago, this is what we have today in that part of the ocean. We have zooplankton. So this is animal plankton, I think in this case forams, which are the nosh for the fish, for the rest of the food chain. 125,000 years ago it was plant plankton. It was phytoplankton. Complete transition in a world that's 1 to 2 degrees warmer, an ocean that's 2 to 3 degrees warmer in our primary productivity. I don't pretend to be a biological guy or understand ecosystems, but I suspect that has an impact. And this is just one example of how things are changing. We know they're changing right now. We know the effect on the salmon fishery around Marlborough, the ocean's getting warmer. We know that partly ocean acidification, but mostly temperature is affecting the shellfish industry. But having an understanding of what's happening right now and what potentially will happen in the future is obviously key. So I'm winding up. I think I have 3 take-home messages, all of equal importance. That's why they've got ones by them. I'm not quite sure what happened there. To me, in terms of our future management of the coastal region and the ocean, an understanding of sea level rise is clearly important. I think we're woefully underprepared. And this will kick us. We'll see this in the coming decades. We won't have to wait for our children to see this. But the influence of subtropical water masses and the contraction of the Antarctic influence, I think, is huge. And this is areas where Melissa and Lionel Carter are doing a lot of work, but they need to be linked up with the biologists, the ecosystems people, so we can understand some of the implications of this, which will almost certainly have economic implications for us in the future. What was the final? Well, I think I've covered those are the 3 things really. Yeah, so that's about it. Yeah, so there's a flavour of what some of the science is telling us. It's a huge area, ocean science, and I've only just scratched the surface on a few things, and in a very light, probably unrobust way if you're a scientist sitting in the audience. But hopefully it gives you a flavour of how that affects us in our part of the world. Thank you.